Welcome, and now we're going to get into the main topic of Chapter 4, this least squares regression line, LSR. And so we've already seen scatter plots, right? And we know that we can create a scatter plot to model the relationship, I guess not model, but investigate the relationship between two quantitative variables. And so in that scatter plot, what we want to do is come up with some sort of mathematical formulation that describes the scatter plot that we could possibly use to predict relationships between the explanatory and response variable. That process of predicting, we talk about that as modeling the relationship. Okay, so to do that, you can see on this graph, we have a scatter plot. The blue dots are shown, and then we have a red line cutting through the middle, and that red line we call a regression line. All regression means is that we are looking at it's a measurement of the relationship between the explanatory and response variables. Okay, so it's a line measuring the relationship between the explanatory and response variables. We're not going to dig too deep into the calculations here because just like when we saw the calculation for the correlation coefficient, the calculation for the regression line is intense, and that's why we leave it to technology, okay? But main thing that we need to know is this regression line predicts how much change we expect to see on average, key phrase, on average, in the response variable, okay? And then that's due to changes in the explanatory variable. So we're not actually looking at the prediction on the amount of change in the explanatory variable, it's all on the response variable. Okay, so when you're looking at this, or when you're analyzing regression lines, be careful. Okay, so you can create your own definition of a regression line that is more or less than what I've already explained here. Okay, so now before we dig deep into, kind of the idea behind this least squares regression line, I think it's actually more useful for us to construct it. So there is an Excel file that you can access, and then there's just one sheet in there, and we're going to open that up and find the regression line. And this is the Excel file that accompanies the lecture here. And so this is an example or the context, I should say, that we've seen already. It's investigating this question if fidgeting keeps you slim, and there's this non-exercise activity, and then so that's measured in calories, and then there's a fat gain associated to that in kilograms. And so we're saying that the NEA change is as the explanatory variable that is causing or is related to the fat gain. Okay, so we're looking, and I misspoke, I should not have said causing, but we're looking for a relationship between these two variables. Okay, so we made a lovely scatter plot, and we did the correlation last time. Okay, now to go into Excel and create a regression line, all we have to do is in our chart, so remember there might be that plus, otherwise if it's not there, just go into design, add chart element, and Excel calls regression lines trend lines. Okay, so just be aware of that. And then you go and select a linear trend line. If you're doing the plus, it's like you have to go to trend line, linear, and then you can see this trend line pop up. Okay, knowing the equation of this trend line is going to be very useful. So if you just double click on the trend line in Excel, this sidebar pops up, and there you can display equation, and then eventually you're going to want to display this r² value too. We'll talk about that later on. And then it pops up this little box, and I have to move it sometimes because it's kind of hard to see. But nevertheless, I get the equation of this trend line, the y equals, and this is appearing in the form mx plus b, but know that when we say it, it's going to be bx plus a. Okay, and then we get this r² value. Don't know what that is yet. We'll talk about it. Okay, so there we go. That's how we can get our, in a scatter plot, that's how we can get a trend line to appear. And how did Excel find that trend line so quickly? Well, this is where you all fast forward if you need to. But the idea is that the reason we call it a LSR line, a least squares regression line, is because to calculate the line, what Excel does is it looks at the squared differences in the vertical differences, I should say, the squared vertical differences, and tries to find the smallest value of those vertical differences. So here's kind of like your let me call this change in y2, so the change in the vertical height, and here would be like change in y1, and then we calculate this. This would be the change in y3, and here that would be the change in y4. So it's looking at all those differences in the vertical all the vertical distances from a line. So it kind of like puts a line there, measures the vertical difference, and then tries many different lines and uses the line that has the smallest overall total difference in the vertical heights. Okay. Now, is is there a reason we have to use the vertical heights? Can we use horizontal heights? Can we use something else? For sure. It's just the least squares regression line is commonly calculated using the vertical differences. Another idea for least squares is to literally compute the area of a square. So you can look at, how not only the vertical height, but kind of the horizontal height too, and make a box from that and see how that calculates out too, and use the minimum of that. There's many different ways of finding a regression line. The least squares regression line using vertical differences is the most common one. Okay, now, so when I use the acronym LSR, I'm referring to the least squares regression line, effectively the trend line, in quotes, that Excel gives you. Okay, and then lastly, how do we use it? Okay, we got this equation, what do we do with it? Okay, so we found that the LSR line was y hat. Okay, so this is literally y with a little caret on top. Okay, and this just means predicted y value. Okay, because we may or may not have that value in our data set. So we're just kind of saying if we had the y value, we'd expect it to be this. Okay, but anyway, we found the LSR line was that. Estimated fat gain. Okay, I have y and x. What was y and what was x? That's where you might need to refer back to the context. And so we just quickly open up Excel to refresh our minds. Okay, so that NEA change was X and the Y was fat gain. Okay, now I'm ready to do this. So I'm looking for, and remember fat gain was a Y and NEA change was an X. So this is effectively asking me to calculate what Y hat is if I know or if I know X is 200. So negative 0.0034, substitute in 200 for x, and then plus 3.5051. Okay, and this is where you grab a calculator. And when I did this, I got 2.8251. And so this is a context. I should respond in context. So doing that, I should say, we estimate the fat gain is 2.8251 kilograms. Okay, using the unit of measurement there. Okay, is the vertical intercept meaningful in context? So again, vertical intercept would mean x is 0 when y is something, right? And that's just our y-intercept. Okay, so y would equal 3.5051. Okay, and in some context, this number is going to make sense. So this means that for an NEA change of 0 calories, we expect a 3.5051 kilogram fat gain. And then we have to, when we write that out, we want to say, does that make sense? So if we don't fidget at all, could we expect a gain of 3.5 pounds? Yeah, this is meaningful. So I'm going to say yes. Okay. And then interpret it, and then I could go on and explain it if I want. I'm not going to for time purposes. Lastly, what does the slope of this line mean? Super, super important that you know how to interpret the slope. Okay. In general, we say for a 1 unit increase in the explanatory variable, your x, we expect a blank, so this would be your slope, and then unit, okay, increase in your response variable, okay? And certainly if you have the units, you can include those, okay? So for my, so this is the general, okay? So this is in general. But now if I want to do this for my context, I'm going to say for a 1 calorie change in NEA, we expect a negative 0.0034 slope, and then this was a kilogram increase in the response variable, which is fat gain. Okay, and certainly there's other ways you can word this. I mean, negative increase, that's kind of awkward. You could say a positive decrease, that's fine. So any variation thereof, but as long as you have this general sentiment conveyed, you should be good. All right, so big ideas here. Regression line, you can use Excel for all the calculations. We've actually hidden all the calculations from you. And there's that idea of least squares regression line, and make sure you know how to use it.